Bismillahirrahmanirrahim. Assalamu alaikum students. Let's start with the topic of Latch, which is also known as a transparent latch. As we have seen that in SR latches which we have discussed in our last lecture, there are some uh, we can say the indeterminate states which we want to be prohibited, and so to eliminate those undesirable conditions of indeterminate states in the SR latch, and to ensure that S and R, both the inputs of the latch, are never equal to 1 at the same time. And this is done in the uh, de-latch process, as you can see in the figure uh, of de-latch. This kind of latch has only two inputs, which we can say that a D input and an enable input, or we can say the control input. And this D input is known as the data input, and C, or control input, also known as enable input. The D input goes directly to the S input, and its complement is applied to the R input. So as long as the enable input is at 0, the cross-coupled SR latch, these cross-coupled SR latch has both inputs at the level of at the level of 1, and the circuit cannot change the state regardless of the value of the D. So D input is sampled when enable input is 1, and if so, this control input, we can say, controls the process of the this D latch circuit. And when D is equal to 1, the change uh, occurs, and the we can say the Q output goes to 1. When D is 1, after enabling the circuit by giving enable input or control input a value of 1, and when we give D is equal to 1, this Q output will be goes to high, or will be equal to 1, placing the circuit in the set state. And if D is equal to 0, the output Q will goes to 0, as we can see in this function table. uh, if D is 0, output Q goes to 0, placing the circuit in the reset state. So simply by changing the value of D, we can change the state of the latch to set our reset state. So when the output Q is equal to 0, the Q prime will be equal to 1, and when Q is equal to 1, and Q prime will be equal to 0. So the D latch receives that designation from its ability to hold data in its internal storage. It is suited for use as a temporary storage for binary information between a unit and its environment. The binary information present at the data input of the D latch is transferred to the Q output when the enable input is asserted, or we can say when enable is high. The output follows changes in the data input as long as the enable input is 1, or enable input is asserted, or we can say this control input is 1, as we can say in this we can see in this function table. So this situation, we can say, provides a path from D input to the output, and for this reason the circuit is also known as a transparent latch, because it transferred the input as it is to the output of the function. When enable input signal is deasserted or is low, the binary information that was present at the data input at the time of the transition occurred is retained, that is stored. So the condition will be as it is, as previously, uh, at the Q output until the enable input is again asserted. So here the notable thing is that an inverter which we have placed at this position, and it will never let both the inputs of the SR latch to become one and one, which is a, we can say, indeterminate state. When we inverter could be placed at the input, then depending on the physical circuit, the external enable signal will be a value of 0, active low, or active high. So we can say that we can use an inverter at the at this control input or enable input to make this circuit active low, or without inverter or active high. So the we can see this is the logic diagram of the D latch, and the different various graphic symbols for the latches are shown in this figure. A latch is designated by a rectangular block. Uh, we can, as you can see here, with the inputs on the left side and outputs on the right side. One output designates the normal output, and the other with the bubble designate the complement output. So the graphic symbol for the SR latch has inputs S and R indicated inside the block. In case of a NAND gate latch, bubbles are added to the inputs of the SR latch, as we can see in this S prime R prime latch. These bubbles are inserted and we use the NAND gates. And in the case of the symbol for the D latch, it's you can see it here. It has input of D and a control input or enable input of C inside the block. Along these are the inputs for this case, and these are the different graphic symbols, and how this D latch works similarly as the SR latch, but only it we can say we use this D latch to avoid the indeterminate conditions which occurs in the SR latch previously. This was the lecture about the D latches. In our next lecture, we will discuss about the flip flops. So take care. Allah Hafiz.